Let me see. Doesn't come, okay. Okay, 10 minutes speaking of that. I lost this sense of time. So we have in Spanish we have a word for trying to imitate French. Okay. And I don't know if this verb even exists in English. Maybe is that the reason, because the nail didn't work because of this missing screw. You was already broken. Okay, you testify with my favor, will you? Okay. So what is that? I think this is a valve or something. Anyway, I didn't do the unboxing because when I tried to, but the technician that keeps all these experiments say, oh, that's the Magdeburg spheres. That's the name in science, because in Magdeburg was the first time this experiment was carried out, in the city of Magdeburg in Germany, in ancient Prussia, I think. They did the vacuum in it was like a brass or brass. Bronze, you know, the bronze. Yeah, anyway, I don't remember. The mixture of two metals, you know, is very resistant to corrosion. It's like it's copper and stain. Too tired. Anyway, and the vacuum was made, I don't know how, maybe with fire or with a pump, and then two horses pulled from the two sides and weren't able to separate. And then when the valve was open, yeah, exactly as you saw. Look, it was carried out by Otto von Guericke. Look, the sphere and the two horses, but it's in the series. In this case, is made out of steel. What's this? Auto historical. Doesn't say this is the representation of the experiment. You know, when they drew. It's a gravure. Yeah. With 8 pairs of horses, 16 horses. I thought it were 2 horses only. Yeah. You could estimate the force that needed. Yeah, we can do it because we are physicists, baby. Yeah, 1 kilogram per square centimeter. Remember what I told you? 1 kilogram per square centimeter. If we calculate roughly the diameter or the radius, we can calculate. But I don't have a thing on ruler. Yeah. Anyway, here we watch 10 centimeters. 10 centimeters diameter. We can calculate later. I was trying to show you the. I promise I won't complain anymore. So, this, whatever you call it, works the same way. So when you press, you get air out of it, so you can use it to, I don't know, for your, so. Okay, you're familiar with that. But what you didn't know is that what holds this rubber, whatever is the name, stuck to the wall is just the atmospheric pressure. Just atmospheric pressure. Okay, so see, to be able to remove it, I just have to let air enter. Okay, what I was trying to do. This is my precision screwdrivers. Just so curious if this is the traditional ones. This is 40 minutes, that's enough. I didn't say much, but you understood what happened, right? Let's make a quick summary. In the 16th century was discovered by Blaise Pascal, or it's a hypothesis by Blaise Pascal at the time. Blaise Pascal is a French monk. I think he was in a kind of how do you say, not very clear religious organization. So, but anyway, Blaise Pascal, his name was immortalized in the unit of the international system of pressure, which is the Pascal. So make a hypothesis that here at the sea level, this is near the sea level, and it could be anybody at the mountain. So we live at the bottom of a sea of air. We live at the bottom of a sea of air. How much time? Okay, I have more time. Good. Yes, so that's why when you climb a mountain, you had difficulties to breathe because there's less air, because there's less pressure. And what we did here with our sphere, in the moment that we get our air out of it, you know, this pressure coming from all directions, yeah, we'll see one day why it's coming from all directions, hold the sphere together, okay? So it's difficult to separate. So what it says here, it says something about a Latin expression called horror vacui. Horror vacui. It means horror to the vacuum, or vacuum horror. Because people, let's see, they thought that it said, this is the other way, different way I thought. It says that horror vacui is because scientists at the time thought that the vacuum didn't exist. They considered that it was horrible and I think and it couldn't exist. So they were horrified by the idea. But it was proved that but the full vacuum, 100% vacuum, it's impossible, right? So the world would collapse trying to destroy it. But I have a friend works in solid state physics and does a lot of vacuum. I don't know how much, but when you consider vacuum, maybe it's, I don't know, 1/10 of the atmospheric pressure. But they are much higher vacuum, you know. But it's becoming more and more expensive. The instrument he uses, and don't tell him I told you. The instrument he uses to make the vacuum costs 300,000 euros. You know, very expensive.